Okay, I want to ask the following through the Canvas as well, but I want to kind of, I think today will be a longer class. I'm almost done in making up the midterm question. And I just want to let you know the midterm is not really about correctness, but it does touch a few important operating principles, but is a lot to do with how creative you are in leveraging some of the concepts you learned to represent very interesting situation. So naturally, you will ask me, well, how should I prepare for the midterm? Let me give you an example. I will actually, by the way, the reason I need to make an announcement right now is Wednesday, I will spend the whole class as well as discussion actually talk about that process. So this coming Wednesday is not going to be participation credit. It's going to be focused on the midterm. Okay. So how should you prepare the midterm? I mean, number one, you should be familiar. I mentioned already, I'm not going to test anything about pointer, especially the syntax. I feel, to be honest with you, as an instructor, I feel if you are going to write code in C or C++ touching pointer, if you got that job situation, you will eventually get it. Sooner or later, that's okay. But there's something which is more important is like a creativity and principle. So you don't need to worry about like the syntax, what is the meaning of and. I feel those are peripheral concept to the curriculum. But instead, you should worry about what is the most important idea of data encapsulation. What is polymorphism? What is inheritance? And what do we mean by operator overloading? Those kind of key concepts. And I want to push you to apply to a fairly complicated scenario. There are multiple things you will see. I will talk more on Wednesday, but many of the Marvel, right? How do I pronounce that? Like Doctor Strange. Those kind of concepts, if you haven't watched those movies, it's interesting. I mean, for example, we talk about person, right? We talk person. What's the concept being laid out in the movie? Maybe first series, second series, like a multiverse, right? Anybody heard about the concept multiverse? Yeah, some of you heard about that. What is multiverse? The same Doctor Strange is actually happening in multiple universe. So if you think about that, our current modeling is GPS. Is actually what? In one of the universe, right? So the thing is that, wow, because I want to model a person, what Dr. Strange is a person, and he's actually appeared in different universe, that's called multiverse. And the thing is, how do I actually model that? And the thing is, of course, I will not ask you anything about multiverse, but the thing is that if you want to relax a little bit, watch some of this movie. The thing that I want to tell you, what I'm going to ask you is related to what happens to a person, a real person, but he has multiple agents. And one of the agents is actually interact with other people on a different space. So one of this is on this cloud space, or one of this is on Discord, and one of this is on different space. And the thing is that this person might have a different personality they want to present, but they're all related to a single person. Or you think about a robot, relationship with a robot and a person, and some of the people cannot do certain things. So they rely on the robot to do something. But the robot is interesting because why? It's a multiple inheritance between a person because it represents that person. It's also a thing with a physical, mechanical. We can think about that the midterm exam, I'm going to give you a scenario which I'm going to give you before the exam. You know what the scenario, but then I want you to come up with application, especially I want you to think about, I'm actually thinking why I want to model a robot in a multiverse this way. because I'm actually thinking that this particular person has some disability. And therefore, he actually needs the other person to be an agent and not a real person to actually together to actually help that person to accomplish something otherwise he cannot accomplish. So I want you to actually think about how you should model according to the application you have in your mind. So I'm going to actually give you the scenario and give you a lot of information about what you need to do. Then how I'm going to grade it? Number one, whatever you design in the C++ class, you will need to justify whether your design met the requirement of those object-oriented design principles, such as abstraction, encapsulation, overloading, polymorphism, and also inheritance. Remember, even in my class, I said sometimes they conflict. Sometimes those principles, you cannot actually be able to handle them together, and therefore you need to justify in your application what you think is the most natural way to represent that complicated scenario. So that's just like, you know, Wednesday class is very important. We will go deep. Probably I'm going to spend 2 hours on that. So I want you to have at least a few weeks. You can marinate that idea, and then when you come here, you will actually see the more detail about exactly what I want you to do. So prepare to actually draw a lot of circle and try to define. I'm not going to ask you to write too much code in the exam because I think that is just syntax. I feel I'm more important to see how do you actually be able to represent the class hierarchy that is and has a relationship, and also how the interface is designed such that this object could interact. I mean, for example, the class record you have done for homework assignment number 2 is actually a way to represent, well, how do you actually going to represent the application I want you to think about, okay? So just let you know, Wednesday will be important for that. So because I need to gear into that, so today I have to finish the multiple inheritance. So this is what we talked about last time. This is what we talked about last time to kind of give you some idea about pointer. And initially, I was planning to go into this to talk about, well, you can see that last time, the pointer is an address. And the address is just a bunch of bits, can be interpreted as integer or anything. You can interpret as floating point if you actually do it right. So, but there is another very important thing about pointer is that pointer actually is an array. Any pointer is an array. And therefore there is like a notation, any notation about a multiple dimensional array can be linearized into something like that. I mean, in principle, I always show this picture. How do I actually show an array? This is to show you an example of two-dimensional array. I mean, in reality, in memory representation, for any programming language I'm aware of, okay, any is just C, you get to see that. Other programming languages hidden from you. It's essentially this process called linearization. It basically represents a one-dimensional array, so you can nicely fit into the memory cell, the memory bank I talked about last time, okay? And therefore, whenever you want to access a particular element of an array, it's actually equivalent to the operation on the M. Where's the M? M is the address of the first byte of the array. And essentially, it's just using the XY to actually calculate the address. And so the whole thing between this pair of parentheses is an address of the element of MXY. And then you just put a star. Then that star is the reference from that address that will access to the element. So that's actually another thing is very important for C programmer to actually know that address is actually array array is also address as well. Okay, internally, that's how they always calculate.
I mean, you can actually generalize this to handle any dimension of array. Okay, that's just something which you should know. Okay, I'm going to skip this part because I think you will learn eventually. I'm going to skip malloc and free. I will come back to malloc free and talk about something called C++ have a concept called smart pointer, which is a very significant improvement over the traditional pointer. I will come back to those later. All right, so I'm going to talk about inheritance. Okay, I'm going to talk about single inheritance and multiple inheritance. So we already talked about single inheritance last week. So single inheritance, for example, this is a single inheritance. It has, I actually kind of make something called core, and then I have a person and thing and IoT thing, and then proxy IoT thing, things like that. This is all single inheritance. The definition of single inheritance is that a child has only one parent in this tree. So the tree is hierarchical, and it represents the root of the tree is the ancestor of all the class. So this is called single inheritance. Okay, so multiple inheritance, by definition, that you're going to have multiple parents. A child class is a multiple class. Those are multiple parents because you realize it's actually very cool. I realized there is something, a new class I want to define. It has a property of multiple parents. And then it will be nice if I can somehow combine the property from two parents and put it together, and then I will have a cool new class. And that's actually very attractive for us to use the concept of multiple inheritance. So one of the example I already mentioned is, for example, robot. I mean, robot, you can actually view robot as a thing, but you can also view robot as a person. If the robot has some capability that need to represent, need to be treated as a person, then essentially a robot is also a person. Okay, I'm not trying to argue philosophically what robot. I'm just using example to teach object-oriented programming. I know it is a huge debate in the ethics, in the philosophy about what is, can a machine be treated, can artificial intelligence be treated as a real human being? For example, things like that. People has loved to discuss and debate those issues for a long time. Okay, so assuming I want to represent a concept, a robot is a thing, but it's also a person, then in modeling, I can actually make a class robot, inherit from person, inherit from thing. So I actually have both the property of a thing and a person, and then that's multiple inheritance. Okay, so that's a general principle. So now I'm going to tell you a little bit subtle difference, which is, okay, to talk about multiple inheritance, I have to give you a warning. This part of the subject is very subjective. Very subjective means that it really depending on how you want to use it. It really depending on what your angle to cut into the subject. And then you determine whether it makes sense to do that. That's why it's similar to the midterm. The midterm, I'm going to check for the grade for whether you are actually familiar with those basic object-oriented principles. And the second thing I'm going to see whether you can apply those principles in a good way or in a very creative way to actually represent a real life problem. Okay, and so that's actually what you can see that the important thing is how you actually be able to apply those kind of things. Okay, I'm going to give you a simple example first. So I'm going to change this code a little bit using this kind of a simple code, and then later I'm going to use a more complicated example. So I have 4 classes defined in this example: account, employee, student, and work study.
account means every member of UC Davis, they should have an account. And then I have a employee is a class, and then employee inherit from account. So because employee need to have account, so account maybe your checking account or your salary or your bill, whatever. Okay. So I define employee, a class employee, very simple one, and it's a public account. And then I define a student. A student is also a type of account. So that's why student is also public account. So now I realize there is a work study student. Okay, work study by definition that this person is a student, but it also has the status of an employee. Oh, so therefore, it's naturally, I'm actually using multiple inheritance. So this is actually, so you already learned this part from previous, right? Class student, public account. So this is the first time you probably see the syntax of multiple inheritance. I said class, work study, public employee, and public student. Let's just worry about public, okay, for all of this. Yeah.
So what happens to the data in the account for work study? Say if the employee account number is different from the student employee account number, from the account number, which account gets assigned to work study? Is both
Okay.
Employee and
Let's find out. That's exactly what I'm going to show. Thank you very much, Amen. So let's actually look at the question you have. So let me ask the question, based on the code, do you think I can draw the is a relationship? Looks like this.
Yes.
Yes? Okay. Then I'm showing you a different way to draw it. I have another way to draw. You see that? I actually have a two account. One go up with similar to your question, right? Go up from employee and one go up from student. So which way do you think makes sense?
Second one, the one on the bottom.
The one on the bottom makes sense?
Like
They both make that exactly. That's why I'm saying there's no, it's a subjective. The subjective is what you want to accomplish, right? So if the way you modeling is that you let your immediate parent class sharing their superclass, then is the bottom one, right? But if you realize that actually the student need to have their own account and the employee has a different account, so meaning that they're going to have two different accounts. So here is a difference. If I want to apply this account to the email account, if I want to have this to the email account, then probably UC Davis, I will use this. This account is email account. But if I want to do this account as a billing account or something, then that scenario work more reasonable, right? So this is actually, you can see that it's not about syntax. It's about what it takes to better represent the real problem you want to deal with. Okay, so that's included. Okay, then I'm going to ask you, with this code, with this piece of code, this is called multiple inheritance. With this code, you think that the compiler is going to produce a real object or real class according to this one or that one?
Depends on whether or not you call the parent, the structure of the parent class inside the child class.
Well, I actually define as it is syntactically, just like this. Yeah.
I think it's gonna be the top one.
Yeah, so that you're right, Kevin, right? Yeah, so this is right, that if you actually define in C++ this way,
So C++, when we use the concept multiple inheritance, is really no merging after you actually pass the first layer. So you're actually going to have the top. That's actually multiple inheritance.
Well, but how do I actually, so this is the answer. So how do I actually want to, because I said sometime I want to do this. So the trick we need to learn here is, well, how do I actually represent this in C++? C++ use a different term called virtual inheritance. So when you do virtual inheritance,
It's not a child level, but in the employee and student level, you see that there is a public virtual. There's two. You have a public virtual. So
that's kind of the syntactic way you can represent. You add a word virtual here for employee, you add a word virtual at the student. And then this means that this two class, when they have a multiple inheritance child, want to use both of them, they are going to share the one copy account on the top. Okay. So just to let you know, there are two things you need to know. If you know this, pretty much you understand everything about multiple inheritance. Of course, I'm going to talk about the pointer stuff a little bit later, which I really think that the understand pointer is for more advanced. If you want to do like a pure programming language research, you want to do that, you want to understand a little bit. But if you want to use multiple inheritance, these two slides are most important for you to actually, for example, handle the midterm question. So number one, you should know there are two different ways of doing multiple inheritance. One is called C++ called multiple inheritance. The other way, C++ called virtual inheritance. And the difference is whether the first layer parents, they will share their superclass because they actually have the same superclass, okay, in this case. I mean, of course, this is like a two layer. It could be multiple layer as well. Okay, that's number one. Yeah.
Virtual inheritance, they get the same copy from the parent class.
Right.
But for non-virtual, you get two copies of the same class.
Right.
Why would it matter if you have two separate copies of the same?
It is, for example, if I decide to, if I have a two copy, right? Which means that I have a way to actually tell my system which copy I would like to do update. For example, I want to update account information. In the top, then I have to say I want to update the employee copy of the account, or I want to update the student account. And even though they belong to the same student, same person, which is the work study person. And therefore, it matters because you actually keep tracking two separate copies. And then when you want to retrieve the information to do your computation, you also need to specify which copy you want to get.
So you can modify the parent class copy.
Yeah. Yes, you can actually modify that, especially if I define as public, or you provide the member function in the account interface to allow people to set and get, right?
Okay, so if you're in employee, you're in the employee class, you can modify the copy from accounts.
Right.
From employee.
Right. And to just follow your question. What's your name again?
Tyler?
Tyler, yeah. So Tyler, follow Tyler's question is that if I'm a work study student, and what I need to do is first I need to cast myself into employee. So this is another way. How do I actually push myself to student or employee using casting? So it's so useful to learn how to do casting. And I cast myself to an employee, and then I actually from there I access to their account. That's how multiple inheritance. Yeah, Kevin.
No, superclass means that it's just the relationship between account and the work study. I use super parent, or there is no such thing called superclass in C++, but I use kind of like a grandparent. I should probably use the word grandparent. Yeah. Yes. Oh, that is just an example. You can put anything. Okay, any question? All right, so the first thing you know is that there is a difference between multiple inheritance and virtual inheritance. Virtual inheritance means that you got to share the grandparent. Now I know I should use the word grandparent in this case. Okay, that's the first thing. The second thing you want to learn from this lecture, which will essentially you complete your knowledge about multiple inheritance, is that how do I actually specify in my code to separate these two cases is actually I said you just add the keyword virtual between the relationship between the parent and the grandparent. If you do that, then you actually accomplish this. Okay, so that should be fairly straightforward. Two difference, virtual inheritance versus multiple inheritance, and you know how to actually tell the system or tell the programming language which one you want to do. Okay.
Can we create multiple virtual objects?
Yes.
Okay.
Yeah, you can do fairly complicated, but I feel multiple inheritance is actually very powerful. We can certainly do a lot of powerful changes in the hierarchy. Is the more we create the complication, it's look like actually if you do this enough, I think the Disney should invite us to actually be able to write the script for next multiverse. I mean, I have problem. I mean, how many of you watched the second movie of Doctor Strange? I mean, that's complicated. I feel complicated, and I think they have a flaw. I think they have a flaw about switching here and there, and I have to watch WandaVision. My daughter said, no, Dad, you have to watch this before you understand that. So I don't know, maybe I missed something because did I tell you I always watch the first 5 minutes and last 5 minutes? And that's the movie, which is I still think that I can actually write a much better script than whatever the company MCU is doing. Okay, all right, that's just for fun. All right. So now you know the first the multiple inheritance and virtual inheritance. Now I want to very quickly to actually show you a piece of code for you to actually be able to see the memory layout. Okay, the following, from my perspective, I think is good to cover as a material, but I think is a secondary. So for a C programmer, we always worry, okay, all right, you have this, but how do I actually put this in memory? Okay, just like when you do malloc, let me actually go back to one example so you see that what I'm talking about. So if this is a typical C code when I define struct. If you're a C programmer, you probably learned this. If you don't know this because you never written a C program, just bear with me, follow this. It's essentially, this is a C version of class. It has all the data structure. And the data structure basically say within this structure or within this class called planet, what are the attributes? What are those attributes you have over there? And the thing is that when we do something called malloc, when you have a struct, you usually have to use a dynamic memory allocation to allocate that. You want to create a lot. And essentially what they did is I have to look at the memory layout. The memory layout looks like this because you can see that the first attribute is name string size 10. Okay, I want to allocate
a size 10 array, 10 character. And the thing is that also let you know that everything in C or Unix, when they allocate space, is always power 2. So therefore, sorry, there's a power of 2 divided by whatever, the 4 words. So the 10 character is actually going to be, for a 32-bit computer, is actually going to allocate 12 bytes. So sometimes you have to be careful that there is a 2 extra byte that being put in the struct. Because you allocate for 10, but I'm actually give you 10 to actually fit to that memory alliance in the typical system. And then the second parameter is diameter, that's the next 8 byte. And then I have an integer moon, that's actually this 4 byte. And then there's another double. So usually we call this memory layout. Means that when I want to implement a structure like a struct in memory, then I need this amount of memory space in order to handle that. And then you can actually use pointer to actually jump from here and there, and then you can actually access to that. So that's for C programmer. Similarly, this is actually for C++ programmer that we have to worry about memory layout. So I'm actually going to show you the memory layout for what I call the multiple inheritance first. So in multiple inheritance, remember I have an employee, and employee has an account. So whatever memory space needs to support the account is going to put it here. And then whatever support the employee class is going to support it here. And then you actually have a student, then you have an account, and then you have a student, and then finally you have a work study. So this is the memory layout when you want to create a class, work study. And by the way, if you only want to create a object from class employee, you will actually only have this 2 part. If you want to create a student object, you only have this 2 part. So only when you create a work study object, then you are going to have all 5 elements. Okay, so that looks good, right? I need a space, and then the memory is there, and then you have to put everything here. Okay, so here is a casting. I want to talk a little bit about the pointer. You can see that when I actually create a work study object, where's the pointer? The pointer to that work study object is always the first byte, the address of the first byte. Remember, a pointer always pointing to the first byte of any data object. The basic data type or object-oriented data type is always pointing at the first byte. Okay, so that's what happened. Okay, now we have to see, because we talked about casting, right? So when you actually cast that pointer called WSPTR, you casting with employee star. This is related to Tyler, your question earlier. How do I know which one I have, right? So when you actually casting the employee star, then essentially this pointer will point to the same thing. Why? Because now you're treating your pointer as a pointer to employee object, which is this 2, right? I mean, this is 2. So the whole thing is work study, but this one, this 2. So you cast the employee, the pointer is going to change. It's not going to change, still point to the first byte. Well, but if you're actually casting the work study pointer, work study students pointer to student star, then basically the pointer get moved down here. And then essentially because why? Because now this is a student. So this is very interesting. So means that in C++, because of the inheritance, when you do this kind of casting, the address is going to change because it was here and it was here. Just to let you know, if you take an ecs36b, if you've done a lot of this kind of casting in C, it will never change the address value of that pointer. Never change. It changed the type for the compiler, but never change the value. But in C++, because of the inheritance, when you do casting, it actually changed. I mean, why I know that? Because I was a C programmer, I did casting a lot, and I thought casting is just tell the compiler about the data type. But then until I write code about inheritance, I realized, oh, the value actually changed. If I need to do some computation based on the value, then I will be in trouble. I mean, for example, let me tell you that. How do I know if this object, these two objects are the same object? How do I know these two objects are the same object? I usually take the address, right? So I use the address, and that's an unreliable one. And so I compare the address, but I do a casting, I realize I cannot do that anymore. Okay, so that just let you know. Yeah.
Is the pointer point to the account or the student?
Point to the first byte of the account. See, the memory layout is that the first portion of the bytes are for the account. And then the next few things are for the student. So what happened is that if you actually move over, the first byte is always point to the first byte, which is account. Okay, and this is good if you casting account, it will still stay there. Yeah. Yes. You said this one? The first one? This one or this one?
Yeah.
This one, yeah.
I don't know what.
Oh, how do I know is it E or S? Okay. In fact, I actually don't know. It's a compiler to decide. The code usually is E because when you do work study, the employee go first. So that particular compiler is actually picking up the first one to be on the top. But we could actually write a different compiler, which is opposite, to always put the last one first, or we can render them all. Yeah. It's just as a programmer, we don't count on that. Yeah. Okay.
And also, could you go to the previous slide for the memory? Okay, so say I pass to a student, so I'm at the pointer pointing to account student right now. What if I say -1? Would I still be able to access them?
Yes. Yes. You can -1 or minus whatever number to actually go back. So you can actually from this pointer, it's an address, right?
Yeah.
If I know the space over here, I can actually jump.
What happens? But the type would be different. Would they simply, oh, but a pointer is a pointer, doesn't matter.
Yeah,
Right?
yeah, it's an address. Yeah. The compiler might complain a little bit, but it's doable. It's doable. Yeah, that's kind of dangerous about C because it allows you to manipulate the pointer. C is not a beautiful language. Okay, it's like a chainsaw. If you want to use it, you wear your glove and your protection. Okay, just let you know that's I always, yeah. All right. Okay, and people say when I was 20, I remember that time I was 25 years old. I was IBM research. My manager told me this is a little bit age discrimination to share with you. He said C language is for young guys like you at that time. All right, so that's just want to tell you how horrible it could be. All right, all right. So here is a few piece of code. Which is, I'm actually going through this later, but I want to show you the other memory layout. 1 second. So now this is a memory layout. That's actually going to talk about virtual inheritance. Okay, now the memory layout is different. That's why I want to tell you, the good news is that they're different. The bad news is horrible. It's horrible. And you see that now my memory layout looks like this, is that because I only got one account, so this account actually be placed at the bottom. And then I have a work study. These three are the same. Student, employee, they're the same. The relative order between work study, student, employee, they're the same. But I'm actually having 2 pointer being inserted into that. Why is that? Because they are sharing this particular account in the memory. And therefore, you need to use the indirection, just like when we do call virtual function. We went over the concept of virtual function. Virtual function is using a function pointer in a place called vtable. And C++, in all the implementation I'm aware of, they all use a virtual table to address virtual inheritance as well. So vtable is the key data structure for you to implement the virtual function as well as the virtual inheritance and a bunch of other things. So essentially what it does is that the virtual table pointer provide a pointer point to another location. And that location will actually pointing back to this particular spot. So essentially, when you actually access the virtual inheritance, is actually need this data structure to over here. Okay, I'm actually going to challenge you. Do you think it's possible for me to represent this graph? Think about this, okay? Can you actually represent this graph using this type of arrangement without virtual pointer? The best way to understand this is, can you do it otherwise? And remember, you need to be able to do casting correctly. Think about that for a minute.
You could just cast every, would I be able to, I say to account, just go to one, to that memory address, the account S every time?
Let me actually try to copy this, and then let's try to implement this a little bit. Let's have a little bit of fun, okay, to do this. I mean, I enjoy doing this type of exercise because it is ugly. I want to see. So you're saying what? Let me duplicate this. Hold on 1 second. Let me get rid of this. So this is what C++ current implementation looks like this. Hold on, I want to duplicate this. Can you help me to duplicate this? Thank you. Okay, I'm going to get rid of this. Get rid of this one. I'm going to get rid of this. So I have a 4 block, right, of memory. How should I arrange? Amen. What was you saying? I don't have this 4. How do I actually get rid of it? How do I actually represent it?
So I turn your account first.
Okay, let's put the account. Okay, and then employee. There's not too many options, right? Just put this 2 below, right? Okay, so if I have this memory layout, what's the problem? What?
You don't have 2 copies.
I don't have 2 copies. That's intentional, right? I only want to have a 1 copy account. Yeah.
Look to the employee, only look to the employee and not the student. because,
Exactly.
Yeah, the first 5.
If you look at employee, it's there, right? Because employee have account. I have a trouble when I look at the student. Because when I actually look at the student, so let me tell you how was student defined. Student was actually defined, looks like this. Student, if I actually casting or do whatever, the student's view should be like this, right? Should be a student and account. That's the view of a student. And I lost that view if I do this. Yeah. Okay, so what?
In between.
In between. So you're saying that I actually, what's your name? Alright. Alright is suggesting do this. So I kind of move this and then I copy 1 pointer, right? I put one pointer over here. And then I actually put like this, right? Okay. What might be the problem? This is actually pretty close, right? But what could be the problem of this one?
That if you declare a virtual for student, you also need a virtual for employee, so you can't just have one virtual for there.
Yeah. So that is kind of inconsistent, right? So because when I think, what's your name? Taha is actually saying that, remember the code, original code? We actually say both virtual on both sides, right? Both virtual here and both virtual there. And that's actually, that virtual basically gives the compiler information about whether I want to use a pointer or not. If I do what, all right, yeah, sorry, I need to learn your name a little bit better, maybe next time. So, but thank you for, if I do this, it looks like it's actually be okay with one side is not virtual. In that case, I have to say employee is not virtual, but the student is virtual in this case, right? So, I actually never tried. Maybe I can try one side is virtual, the other side is not. But as long as we have a virtual, we have to insert a pointer. Yeah.
But if it's access, like, I guess the grandparent class, which is their account, how do you move down between classes? Because the pointer will point to the top. But I guess how do you?
Okay, that's a good question. So let me ask you, I'm a inexperienced C++ programmer. I actually don't know the question you just asked. I just keep asking, you can push down. But how do you actually keep pushing up? How do you actually push down, right? So we have a definition, looks like this. And now I'm actually an account pointer. I'm an account pointer, okay? That's the top, right? My grandparent, I have a pointer of account. How do I actually move down to work study students? So how do I actually convert a account pointer? Let me actually write it down here. So assuming I have something called account star ACCPTR, right? And now I need to push down to work study, right? How do I actually get to work study? Okay, that's actually for multiple inheritance, right? For multiple inheritance, I need to know because first I have to tell, okay, so that's a good question. Let's work on the multiple inheritance first. For this is multiple inheritance. How do I cast? So I have a count pointer. Now I want to convert the account pointer to the work study pointer, right? I have to know that this is a work study. So, but the account pointer, I could be pointing here and could be pointing here. And therefore the compiler, by the way, compiler can calculate what's the space between these two and what's the space between these two. So the compiler actually know all the memory size because they compile the code. Well, but it doesn't know whether this account is here or there. And therefore you need to first cast it to either employee or student. You have to cast the first time, as I mentioned. And then from there, you cast work study, it will actually cast back. By the way, the pointer to the work study is actually here. I just don't know whether the location I start with is from here or here, right? Okay, so how about this one? If I actually have a layout looks like this, I'm actually have an account over here, right? That's the account pointer. How do I actually get back? it's also compiler can take care of that because compiler know the account is actually virtual inheritance from this two. So the compiler actually know all the layout on the way up. So when you casting, the compiler will calculate the space for work study, student, and employee, plus this two virtual pointer, plus those two virtual pointer, how much space they take. And then add all of them together, and then it will be able to, from this account pointer, all the way jump up to the virtual pointer. Okay, so just to let you know that this is the, I want to go back to here about the casting up and down. So work study, if you have a pointer work study, it still point to the top, just like the multiple inheritance. When you casting with employee, it's still here, and you cast with student is actually here. And this one here is because it's a virtual inheritance. And then if you casting the account, it will jump down here. Essentially what we are saying that if you actually create a class of employee, the memory layout under the, remember you say that virtual, the memory layout actually looks like this. Just want to show you the layout. The layout, if you create an employee object, because of the virtual inheritance, we flipped the position of the account. So the position should look like this. And then where you have the account is a secondary. The important thing is that this virtual pointer is actually helping you to pointing to this account location. Okay, that's okay. The other thing I should tell you that why I'm saying that all this complicated thing, typically in the performance, the C programmer usually care a lot of performance. That was one of the main reasons we prefer to use C over other language, is because C is fast. But if you use a virtual inheritance, it's a slower, because a virtual inheritance require interaction, just like a virtual function. Okay, let me see. I think I pretty much cover everything I want to cover. Yeah, I think I cover everything I want to cover. Okay. Yeah, all right. So I hope you understand the concept and the complication. I hope to see you on Wednesday. I will talk about the midterm index, and which essentially using all the concept we taught so far. Yeah. Give me 1 second. Let me turn off